Hello everyone, welcome back to our channel. Today we are going to discuss about acceleration time graph. Why we are giving more preference to acceleration time graph? These are playing an important role that to almost all automobiles are coming from this application only. So in our bike, in our car, flight, whatever it is, we are using the speedometer. Means speed we are calculating with respect to time. If we want to know the speed, we know the distance and we have to know about the time. So all the applications are coming from these analysis of from mechanics only. First we know the displacement time graph, then velocity time graph. Now we are going to discuss about the acceleration time graph. Acceleration, you know that increasing accelerator is there. When you are increasing the speed, that is called the acceleration. Suppose we want to reduce the speed, that is called the deceleration. So in speedometer, we know that how much distance it covers and how much speed it is going, with how much acceleration, everything we can calculate with the help of simple device that is called the speedometer. But anyway, we have to go through the graphs only. Graphs are very good method to analyze anything about in any field. We can use this one. So here acceleration time graph, you know that basic formula for acceleration is rate of change of velocity is giving the acceleration, velocity at particular instant of time. When we are doing the cross multiplication, dv equals to adt, acceleration into time. From this, what you are understanding, area under acceleration and fraction of the time, it is giving the velocity. Suppose we are taking both the sides integrations, dv equals to integration of adt. So entire system, when we are drawing the graph between acceleration and time, area under that one, it gives the velocity or change in velocity also we can take here. One example, we are taking time is on x-axis, well acceleration is on y-axis. If it is parallel to time, means here you can say a is constant. Acceleration is not changing with respect to time. One more graph we are taking. This is the time and this is the acceleration. If the graph is like this, what we are understanding here, when we are drawing the slope, this is the alpha. Here alpha is less than 90 degrees. So acceleration is increasing in constant rate. Here acceleration is increasing in constant rate. The next thing, this is the time and this is the acceleration. We are taking, this is like this. Here slope of the graph alpha is greater than 90 degrees. So acceleration is decreasing in constant rate. Here acceleration is increasing in constant rate. But here no change in acceleration. Based on this, we do few problems on acceleration time graph. Here the given graph is on y-axis, they have taken the acceleration. On x-axis, we are taking the time. Find average acceleration in first 20 seconds. In 20 seconds, we have to find out the acceleration. In this case, till here only. So this is the acceleration and this is the time. We want to find out the area. Area of this graph is nothing but change in velocity. Area of first part, triangle, half into base into height, you are getting 100. Area of second part is rectangle, base into 20 minus 10 is the 10 into here 20, 100, 200 you are getting. So total area of this graph is giving the change in velocity 300. But the time is, at what time we should find out, till 20 seconds only. So to change in time interval or time we are taking 20 seconds. So average acceleration is 15 meter per second square. Like that, one more problem we are doing. Here in problem, one car is there. That car is moving starting from rest and it is going with constant rate. Acceleration is how much? Beta. After reach to the maximum velocity, it is decreasing to constant rate. Total time is how much? Total time is the t seconds. And constant rate while decreasing, beta they have given. Now we are splitting, this part we should consider t1, this part we should consider t2. Here first problem we should find out the maximum velocity and second part we should find out the displacement of this one. So you know that Acceleration is ratio of velocity and time. So slope of the first part, first rectangle, it gives the alpha, and slope of that second one is giving the beta. So here acceleration, what we are taking, alpha equals to here opposite is V maximum by T1. V maximum by T1. From this T1 equals to V maximum by alpha. Like that T2 equals to, so opposite by adjacent of this one. So beta equals to, first we can go through the beta equals to V maximum by T2. From this T2 equals to V maximum by beta. But total time they have given in our problem, T equals to T1 plus T2. T equals to T1 plus T2. So T equals to, in both the cases which is common, V maximum is common. 1 by alpha plus 1 by beta. From this V maximum equals to, we are getting T into, here one more step, if you want to write, take LCM. LCM is how much? Alpha into beta. While going this side, it comes as a numerator, alpha beta by alpha plus beta. This is the first one. Simply we took the area, slope of that two graphs is giving the maximum velocity T into alpha beta by alpha plus beta. Then one more thing, we should find out the displacement area under this. This graph shape is the rectangle, so half into base is the total time, height is V maximum. Substitute V maximum, you are getting half into V maximum is alpha beta by alpha plus beta. Here T and here also T square. Now we are doing one problem here. One car is there that is going with constant rate. Alpha equals to 2 meters per second square. Like that beta equals to 3 meter per second square. And time equals to 10 seconds. Time equals to 10 seconds. So we know only with how much acceleration constant they have given, with how much constant deceleration and total time. With the help of these three, we can find out the V maximum and displacement. Directly we can go for these two formulas. So how to find out the maximum? V maximum in this case, V maximum, T value 10, alpha into beta by alpha plus beta. So 2 into 3, 6 by 5. V maximum equals to 12 meters per second. Like that displacement is half into V maximum, already you know that V maximum is the 12. Time is the 10 seconds.